How to find your z-scores.
What
are you doing?
It's wallaby.
It might. All right, guys. Shh, I'm recording just to let you know. All right. So, okay. All right. So to find your critical value, it's just a regular z-score. So just like you would find your percent that you need. So we had the 95%. You guys know what I'm talking about. And then we picked up the 5% on it. Sorry, 5% split in half on either side. So when we did this one at the very end of our notes yesterday, where we had 99%, and we said that each side was 0.005, you go into your table. This is your table A, your z-scores, just like you found before, and you look for that 0.005. And then, so there's 5.1 and 4.9. We said that it was negative 2.5. And then because these are both the same distance away, you could use either one. So negative 2.57 or negative 2.58. So it didn't matter which one. But you want to get the one that's closest to that 0.005. But that's how you find your critical value, just like you found your z-scores before. Okay? Y'all got it? So doing it by the table doesn't make any difference. You can do it by hand or in the calculator. So whatever you want. All right. So then in your notes, putting it all together. So we're going to start, and we should finish this up, and hopefully it'll be rather quickly so that Ben can get to practice and not be late. You don't even care. It's cool. What? What? Clearly. All right. Taking together the examples about Mr. B's class and the B's activity, show you how to get an inference interval or a confidence interval, sorry, for an unknown population proportion P. We can use the familiar four-step process whenever a problem asks us to construct and interpret. A confidence interval. So here's your four-step process. You're going to state what parameter that you want to estimate and at what confidence level. Cannot spell. All right, so remember our parameter on the other one, we did that. I'll flip it back, the parameter that we wanted to do. And then just make sure they said a 99% confidence interval, so you would put like C equals 99%, okay? And we'll go over one of those in just a minute. Identify the appropriate inference method. Check conditions. What are the conditions that we check? What is random? To make sure what? It's within the definition. Random select, yep, to make sure that it's a random selection or a randomized experiment, okay? So as long as it says that, we're good to go. It'll say it randomly selected, it's a randomized experiment. Huh? Then what? What do you check the 10% rule for? To make sure that it's independent. See, we learned something yesterday. What if it already tells you it's independent? You don't have to do the 10% rule. You got it? Okay, so if you're already replacing, if we're talking about a deck of cards, we're already replacing, then we don't have to worry about it because our chance process or our chance does not change, our percent of getting that card. And then the last thing we got to check is large counts. And why do we check it? To make sure that it is normal. All right, so don't forget that. If the conditions are met, we perform calculations. And then when we conclude, we're going to interpret. We're going to interpret that interval. All right, so this will be the longest state that I expect you to do, okay? So understand that you don't have to put it this precise, but they do want you to define it. And you can define it just like P equals and the percent is whatever, okay? So on the state for this one, the Gallup Youth Survey asked a random sample, so we know it's random, just to let you know, of 439. That's going to be our N. U.S. teens ages 13 to 17, whether they thought young people should wait until marriage to have sex. Of the sample, 246, that's our success, said yes. Construct and interpret a 95% confidence interval, so that's our C level. For the proportion of all teens who would say yes if asked this question. So that's your context of the problem. All right. So to state, we're going to estimate with 95% confidence. This is putting the parameter and the C level all in the same sentence, okay? The true proportion of all. Why do we say all? Because what are we talking about? The population. So we have to say all. Of all 13 to 17-year-olds in the U.S. who say that young people should wait to have sex till marriage. You don't have to write it all out in one big sentence, ever, okay? This is not an English writing class, anything like that. Your conclusion, I would write out in complete sentences. The rest of it does not have to be. All right, so that's your state. Your plan is going to check your conditions, but you also need to tell what you're doing. So this is what you're doing. This is the part that you probably don't know right now. We're going to use a one sample Z interval for P. That was in your, it was a box that showed your formula. Okay, so that's what it said, a one sample Z interval for proportions if conditions are met. So I'm gonna go back over these two because all the rest you should know how to do fairly easy. In the state, you have to tell what you're doing. What is your P? Okay, what are you looking for? The true proportion of all contexts of problem and your C level. So those are the two things that I'm looking for in your state. Got it? Two things in there. In your plan, there are four things that I'm looking for. The first thing is what kind of test is it? Because we're going to talk about different tests soon. So this is a one sample Z. Why is it a one sample Z? How many samples are we looking at? One. What letter are we using? Z star. Eventually we'll use T. So you'll know the difference, okay? You will know the difference. And then it's an interval that we're trying to find. And what are we trying to find it for? For a proportion. You could say a one sample Z proportion interval. It doesn't matter how you say it, just as long as you say it's a Z interval, one sample proportions. Got it? All right. So then the conditions, what'd you say our conditions were? First one is random. Is this random? Why? Random sample of 439 teens. What's the next one we check? How do we check the 10%? 10 times your N, which was 439. Do you think that there are more than 4,390 13 to 17-year-olds in the U.S.? Yes. Sorry, y'all. All right. What's the next one you check? How do we check large counts? Huh? But what is greater than 10? Greater than or equal to 10? Success and failure. So don't forget that. And you don't have to write success or failure. I'm just putting it there for you guys to understand where the numbers come from, okay? So when you do it yourself, you can just write the two numbers, okay? So your success is going to be the 246. That is greater than or equal to 10. Your failure, how do you get your failures? Sample size minus your success. And that number was 193. Is greater than or equal to 10. So we're good to go on the large counts. So what does that mean? We're going to assume what? We're going to assume normality. Eventually, I will show you how to do this in your calculator, but you need to know the formula. So our formula, remember, is P hat plus or minus Z star. We're doing proportion, so the square root of the proportion, 1 minus the proportion over N. And then we need to know what those values are. What is your proportion? How do you get it? Say it again. Yeah, your want over your total. What's your want? What was our success? You could even do success over total. 246. What was our total amount we surveyed or took a sample of? This gives you 0.56. How do we find Z star? How did I tell you yesterday? Inverse norm. If we want a 95% confidence, that means we have what left over? 5% divided by 2 is 0.025. 2.5% or 0.025. That's your area. And then because we're doing Z's, we standardized, which means our mean is 0 and our standard deviation is 1. Again, you don't have to look this up. Memorize this one because this is the one that usually they use. What is your Z star? You guys remember? For 95%, I said it's always going to be that. It'll be worth it to just go ahead and memorize that. I think 95 and 99 are the ones that would be good. I think it's 2.54. So I don't know. We did it a minute ago, yesterday. All right. So because you have all this labeled out, you don't necessarily have to put the numbers in for this. You can, or you can just go ahead and do it in your calculator. If you put your numbers in, 0.56 plus or minus 1.96, square root 0.56, 1 minus 0.56 over 439 gives your interval, I'm just running out of room, sorry, 0.514 to 0.606. Conclude is the interpretation of that interval. How do we start that? We are 95% confident. That the interval, and then make sure you state your interval, 0.514 to 0.606, does what? Captures the true what? Proportion of, and then back up to the beginning, all 13 to 17-year-olds in the US who say that young people should wait to have sex till marriage. And I'm just going to put the little dots. You guys know that that's what you do. If you need to, draw the arrow up to right there where it says all 13 to 17-year-olds. It's very redundant, the plan and the conclusion. Are you done? Girls, we're good at that. All right, everybody good? You complain I write fast, but you complain if I make my meetings fair. you don't get on my nerves. You get on, no. Y'all make class fun.
Well, I keep complaining.
Y'all make class fun. It's the first time I've taught all day. It is. Remember that the margin of error in a confidence interval includes only sampling variability. There are other sources of error that are not taken into account. As is the case with many surveys, we are forced to assume that the teens answered truthfully. If they didn't, then our estimate may be biased. Again, if you're talking about teens and any kind of sexual activity, drugs, anything like that that they are not comfortable with. Obviously, you guys are not comfortable talking to adults about that. You may lie if I was the one giving the survey, okay? If your peers are giving the survey, you may be more truthful with them, okay? All right. So other problems like non-response, and question wording can also affect the results of this or any other poll. Lesson, sampling beads is much easier than sampling people. Beads are not going to lie to you. Beads are not going to not answer clearly. All right, your calculator will handle the do part of your 4-step process as the following technology corner illustrates. However, you may use your calculator to compute a confidence level on the AP exam, but there's a risk involved. If you just give the calculator answer with no work, you'll get either full credit for the do step if the interval is correct, or no credit if it's wrong. If you opt for the calculator only method, be sure to name the procedure, 1 proportion Z interval, and give the interval blah, 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 blah. So where I tell you to still write the formula, but you can do all the work in your calculator, that's what I'm talking about. Okay, so that way they know exactly what you did. That shows that you did that 1 proportion Z interval. It doesn't show that you did a t-test or whatever to get your answer. Got it? So you can get partial credit for putting it up there, but getting the wrong answer. Also, when you go to that next step and you use that interval, they won't count off. If so, your do part is wrong and your conclude goes from your wrong do part, you can still get full credit for the conclude. Does that make sense? If you made sense within the problem. All right. So this should say if n equals 439 teens are surveyed, we said that 246, x equals 246. So they thought that young people should wait to have sex until after marriage. To construct a confidence interval, we'll do this. So remember we said the statistic plus or minus the critical value. And we said that was Z star times the standard deviation of the statistic. We write that 40,000 times to try to get it stuck in your head. So if I've read it 40,000 times, there's a reason that you should know it. So we can do this in our calculator. If you guys have your calculator, it might be smart to get those out. You're going to go into stat, and you're going to go over to test, so it looks like this. And we're doing a 1 proportion Z interval. Will we use more of these things? We absolutely will. Not the Z interval, keep going down. We want a 1 proportion. Why are we using 1 proportion Z interval? Because we have 1 proportion. Does everybody understand that? Okay. Eventually, we might have 2, so we would use 2 proportion. Got it? All right. So 1 proportion Z interval, and if you want to put that on there, that's letter A. It asks you for X. Remember, X is the number of successes. So our X was 246. And then we have our N, which is the sample size. And our sample size was 439. And then we don't have to do all that work in our head to figure out the Z star or any work in the calculator for that matter, like doing the inverse norm and stuff like that, because it'll do it for you. Our C level was 95%. And you want to write it as a decimal, so 0.95. And I think that is your set. I think you guys all had 0.95 when I told you it's the most normal one, okay? And then when you hit enter, you see right above it, it gives you the more precise of what we have, okay? So any questions on that? I do not care which way you do it. What? What? That's your proportion. Are you talking about this? Is this what you're talking about in your calculator?
Yeah.
Oh, are you talking about when you do it? Sorry. This is what you should have. Are you doing the right one? Okay, so, right, make sure you do, yep, interval. All right, everybody good? So again, when you do that, what they give you is that interval, and then they also give you your proportion. So that's your p hat that you found, the 246 over 439. Okay. All right. Flip it. In planning a study, we may want to choose a sample size that allows us to estimate a population proportion within a given margin of error. National survey organizations like the Gallup poll typically sample between 1,000 and 1,500, should say American adults, who are interviewed by telephone. Why do they choose such sample sizes? The margin of error, or the ME, in the confidence interval for P is? We already know this. It's the back part of that formula after the plus or minus. So Z star square root of the proportion 1 minus the proportion or the sample proportion over N. So we already know that that part is the margin of error. We've already done that. So here, Z star is the standard normal critical value. We already knew that again. For the confidence level, we won't. Because the margin of error involves the sample proportion of successes, which is P hat. We have to guess the value of P hat when choosing N. Here are the 2 ways to do this. So we can use a guess for P hat based on a pilot study or past experience with similar studies. You should do several calculations that cover a range of P hat values. So if we don't know what the proportion is, or it doesn't give us a proportion, we can use other studies that did the same thing and use their proportion, okay? If we don't know that, which we will not. So this is the one that's important to you. So if we don't know our proportion, slide this over here because I shouldn't have put p hat value of 0.5, 50%. So we would use that as our guess. The margin of error is the largest when p hat equals 0.5. So this guess is conservative in the sense that if we get any other p hat when we do our study, we will get a margin of error smaller than planned. So again, anytime we don't know the proportion, they don't give us the proportion, what are we going to use? What did I just say? 0.5. So if you don't know it, you're going to use 0.5. So once you have a guess for p hat, the formula for the margin of error can be solved to give the sample size n if needed. You will do this on your next Albert. Okay, there are lots of questions about that. So they'll say, what is the biggest sample that I can have to produce a margin of error less than blah, blah, blah. Okay, so be ready for that. They want to know the sample size and they give you everything else. So if we're trying to determine that sample size, sorry. Oh, that looks good. You did great. Thank you.
Sorry, Bobby.
No, you're good. Sorry, y'all. To determine the sample size n that will yield a C% confidence interval for a population proportion P with a maximum margin of error ME, solve the following inequality for n. All right, so again, the maximum margin of error comes from using that proportion of 0.5. So Z star times the square root of p hat, 1 minus p hat, but again, our p hat will be 0.5, less than or equal to the margin of error. So you would solve that for n. It looks complicated. It is basic algebra 1, okay? It just looks complicated with all the craziness in there, all right? Where p hat is a guessed value for the sample proportion, the margin of error will always be less than or equal to ME, the margin of error, if you use p hat equal to 0.5. So here's an example that shows you how to determine the sample size. So we're going to do one, but again, it's going to look complicated, but it's normal algebra. Okay. Everybody good? All right, so a company has received complaints about its customer service. The managers intend to hire a consultant to carry out survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. One critical question is the degree of satisfaction with the company's customer service measured on a 5-point scale. The president wants to estimate the proportion P of customers, so this is what they want, estimate the proportion P of customers who are satisfied. That is, who choose either somewhat satisfied or very satisfied, the two highest levels on the 5-point scale. So they're ranking everybody or everything 1 to 5. She decided that she wants the estimate to be within 3%, so that's important. The estimate to be within 3% or 0.03 at a 95% confidence level. We want to know how large the sample is needed. So determine the sample size needed to estimate P within 0.03 with 95% confidence. Here's our formula. Z star, P hat, 1 minus P hat over N is less than or equal to the margin of error. What is our Z star going to be? Why is it 1.96? 95% confidence. Remember, I told you you're going to keep seeing that. What's your margin of error? Margin of error is what? 0.03. Perfect. And then the last thing we're going to need is p hat. We don't have any proportion in here. So what are we going to use? 0.5. We're going to plug that in and solve this inequality. Okay. (1.96) times the square root of 0.05, 1 minus 0.05 over n less than.
Wait. Is it 0.5 or 0.05?
Sorry, you are correct. 0.5. Thank you. I was looking at the 0.03 the whole time I'm writing. Very good. How do we solve this? It's an easy question.
Divide by 1.96.
You are correct. That leaves us with the square root of 0.5, 1 minus 0.5 over n. And you can change that to 0.5 if you want to. You can simplify as much as you want to. Which gives you 0.0153.
Square it.
Yep. Basic algebra. I told you guys, basic algebra. Oh, sorry. Ignore the fact that I put that. Struggling today. So now you have 0.5 times 1 minus 0.5 over n is less than or equal to 0.000234. Here's a little cheater method thing that you guys can do anytime your variable is on the bottom. Switch it with the other side. So 0.5, 1 minus 0.5. Now it's going to be over 0.000234, less than or equal to n. And then you can just put that in your calculator. And I just use alpha y equals because it makes it a lot easier. 0.5, 1 minus 0.5, and then 0.000234. Gives us 1068.3. Less than or equal to n. So what sample size do I need to use? What do you think? To be able to get 1068.3. And if I read it backwards, n has to be greater than or equal to that. No. What is your first whole number greater than 1068.3? Yeah, don't make it more. Yeah, it's easy. So we want to round up. To ensure that the margin of error is no more than that 0.03. All right, so that's a lot of work, right? Having to do all that algebra stuff. But it's the same formula that you've been using, right? If you would like a different formula so that you just have to type it in your calculator, it is this. I do not care which formula you use. This one will be harder to remember because you're not using it every single time. We've wrote the other one 40,000 times.
I just looked, man.
Right, but it is exactly what you did up here in 14 steps, all in one step. But you don't have to memorize this because you guys know how to do the algebra for the other part, okay? But if you want it, it's there. All right, flip it over. Why not round to the nearest whole number, in this case 1067? Now, what we did, this number is going to be off. Ours is going to be 1068 because we rounded different than what the book did. So they might not have used 0.00234 or 0.0153. They might have only done 3 decimal places. Y'all understand what I'm saying? So that's why theirs looks a little different than mine. All right. Because a smaller sample size will result in a larger margin of error, possibly more than the desired 3%. So if you want a 2.5% margin of error rather than 3%, then n has to be greater than or equal to. This next part is that formula that I just wrote. So instead of doing all the steps, 1.96, 0.025 squared times 0.5, 1 minus 0.5. Which would give us 1536.64. So here's what I'm talking about. We used 4 or 5 decimal places here. They only used 3. Got it? Everybody good? So that's why this 1067 is now 1068 for us. All right. So we want to make this, instead of 1536, we want to get the next highest, so 1537. If we did a 2% margin of error for the sample, we're going to do the same thing, 1.96 over 0.02 squared, 0.5, 1 minus 0.5, which is 2401. So as usual, smaller margins of error call for larger samples. So if you look at that, a 2.5% is larger than a 2% margin of error, so we have to have larger sample size. News reports frequently describe the results of surveys with sample sizes between 1,000 and 1,500 and a margin of error of about 3%. So this is the typical. These surveys generally use sampling procedures more complicated than a simple random sample, so the calculation of confidence intervals is more involved. The calculations of the previous example still give you a rough idea of how such surveys are planned. So we're going to check our understanding and then we're done. Okay, this is it. In the company's prior year survey, 80% of customers surveyed said that they were somewhat satisfied or very satisfied. Using this value as a guess for p-hat, find the sample size needed for a margin of error of 3% at a 95% confidence interval. Okay. I'm going to use the cheater formula. If you want to do the other one, it'll just take us longer. So I figure you're ready to be done. I'm going to use the cheater formula. So we want 95%. So what's our Z star? 1.96. Our margin of error, we want a 3%. So that's 0.03 squared. What is our proportion? 80, right? It gave us a proportion. Where did it go? Right here. So we're going to use that. If we don't know the proportion, we use 50%. Then 1 minus 0.8. When we put that all in our calculator, all of this, we get 682.951. So what should our sample size be? So N is at least 683. So those will be on your Albert. I know because I've looked at, like going through trying to pick out questions, that these are some of those questions that are in the Albert. So what if the company president demands 99% confidence instead? Determine how this would affect your answer to question 1. So what's that going to change? What part of this is that going to change? The Z star, right? Okay, so can you tell me what the 99% Z star is? How do we do that? Inverse norm. Our area is going to be what? 0.005. And remember, we're just going to use the positive. So 2.58. Everybody okay with that? Rounding 3 decimal places or 2 decimal places. 2.58 over 0.03 squared. The proportion does not change. Only the Z star changed. When we put that in our calculator, we need to have greater than or equal to 1179.69. So N should be at least 1180. So what happened? So if Z star or the confidence is increased, then N does what? Increases. So that's what you need to know. As confidence increases, your sample size has to increase to account for that margin of error. Sorry. Any questions? All right. Zoomers, give me a minute and I'll let you off. Everybody's got this. All right, I'm going to stop sharing. Stop recording.